Continuing our retrosynthetic analysis, we had another target molecule that we were required to use a sulfur ylid for. I wrote the actual wording you would see on an exam for this. Do a retrosynthetic analysis for the target, there's the target, that ends with saturated acyclic alcohols with 5 carbons or less. It's very specific, kind of the more specific version of this. And then show the forward synthesis. So when you're doing an epoxide, what was it right before it was an epoxide and we're forced to use a sulfur ylid? It's not like use the other methods of making an epoxide. So we're looking back. It was an epoxide here, and it was in this case, a ketone and a sulfur ylid. And how do you predict the pieces? Sulfur ylid piece is there, isn't it? Carbonyl, former carbonyl piece was here. Pink was sulfur, and blue was the carbonyl. Okay? All right. Blue piece, pink piece. Blue carbons, pink carbons, connected with an epoxide. Okay. Ylid one side, ketone other side. Could be aldehyde. In this case, it has to be aldehyde because there's no carbons with 2 carbons here or here, right? So it had to be aldehyde. And I don't think it matters which one's the aldehyde and which one's the not aldehyde, the ylid. And if this is an aldehyde, that would be 1, 2, 3, 4, 5, 6. We're still going to have to do an extension on this one. That's okay. A 1 carbon extension is good, and a 2 carbon extension was our previous video, and we have both of them. We're going to use either or both on your test anyway. It's good we're doing this one right after the other one. So I just, in keeping with my theme from the last one, I think I had the ylid on the left and I had the carbonyl on the right. Just left, right for my discerning. And we'll do retro in black and molecules in green. So we wanted the sulfur ylid to be here. And to be an ylid, it needed to have a lone pair and a minus. 1, 2, 3, 4. Oh, we lost the carbon in 1, 2, 3, 4, 5. I just didn't draw it very nicely. There it is. Got to have 5 carbons up to here. And the carbonyl was the other carbon. And we'll do it in baby blue. And there it is. And what was it before it was a sulfur ylid? And yeah, I forgot my formal charge. Oops. That's a sulfur ylid. What was it called before it was a sulfur ylid? And the name of it actually says that. The precursor to the sulfur ylid. So we have an H up there. Yeah, the screen on the right side of the room doesn't have the entire left side of the screen on it, does it? Better? Okay. Can I move those two closer to each other? I don't know. Because I probably didn't grab that. Oh, not the mouse. I've had a lot of trouble doing that in the past. Okay. 6 carbon aldehyde doesn't come, it can come from a 6 carbon alcohol. But you know it's a 6 carbon alcohol, so you know you're not done, is what I'm saying. Aldehydes come from alcohols that are primary. PCC. We'll worry about extending a smaller molecule to become that bigger one. Before the precursor to the precursor, shall we go back? How many back? I'm in trouble going back. Oh, precursor to the precursor. There's the precursor. There's the precursor to the precursor. It's an alkyl halide and a sulfur with 2 phenyls on it. End of story. So I need an alkyl halide with the same number of carbons. We love bromine for some reason. And you don't have to show me sulfur with 2 phosphoruses, but you can if you want. That's not part of the synthesis. It's a reagent, really. And how can I extend this to make it 1 carbon bigger than this? 5 carbon Grignard or organolithium. Or what's it got to react with to make a 6 carbon alcohol? This needs to become this. Epoxide has a minimum of 2 carbons. I got to go back to the start of my day, clearly. Let's see. There it is. You want an alcohol that was bigger and the OH is on the same carbon that got attacked. You use a ketone and an organolithium or a Grignard. If you want an alcohol on a carbon adjacent to the carbon that got attacked, you use an epoxide. I will say again, when you want a new alcohol that has the new bond, the new synthesis bond to the carbon that used to be a carbonyl, you use an aldehyde or a ketone. If you want a new alcohol with the new bond, the synthesis bond between carbons adjacent to the alcohol carbon, you attack an epoxide. This is the first scenario. I need a new bond to a carbon right here that used to be a carbonyl. This carbon used to be a carbonyl. An aldehyde in this case, because there's only 1 carbon, can't be a ketone. And it would be, it's hard to do stick figures for formaldehyde because it looks like somebody made a mistake. They're just doing this. I don't do formaldehyde like that. It's acceptable. If you do it, I'm fine with it. I just don't do it. I write the CH2. And then, hey, alcohol, 1 carbon, made into an aldehyde, 1 carbon. We've done that 3 times today already. Put a highlighter on that. That's an alcohol with 1 carbon. This thing came from alkyl bromide. We do not know how to make Grignards or organolithiums directly from alcohol. Nobody does. Don't pretend you do. You know how to make them from alkyl bromide or chloride, which do come from alcohols. And we'll do the forward synthesis. I'm going to highlight that because that's an alcohol with 5 carbons and no pi bonds and no rings. No pi bonds means saturated. No rings means acyclic. Yeah. Forward synthesis in purple. What chemicals make that into that? It's a chemical. Yes, PBr3. What chemical makes a organolithium or a Grignard? This time I'll make the Grignard with the spectator ion. MgBr plus crossed out because it was a spectator anyway. So how do you make a Grignard from an organohalide? I need a metal and a solvent, just like the lithium one, but they're different. What metal are we clearly using this time? I crossed it out. Magnesium. And when you use magnesium, what's your only solvent that you should think of? An ether. It won't work unless it's an ether. They've tried, trust me. I've tried. Personally, I've tried. Doesn't work. That's the most popular one because it's a cheap ether. THF is another one. If you can't get the diethyl ether to work, you invest a little more and do the THF. And then I got to review how the organolithium combined with the aldehyde to make a bigger alcohol. We're going to go back early today when we had 4 reactions all being compared. And I think it was there. Organolithium, what was the protocol? They reacted together first and then HCl. Sound familiar, right? Same, we already did when we had to show this clearly. It's the same story, right? So let me know that you're reacting the 2 drawn pictures first. I like the parenthesis connecting them. And don't just do this. You're going to get a half point. You got to write 1, mix. That means mix the things that I connected. And 2, HCl puts that H up there. I'll put it purple just so you know. And what chemical oxidizes a primary alcohol to an aldehyde? There's one that we've done twice today, and there's one in biochemistry you could even use here. Well, what's the one we used today twice? It's an oxidation, PCC. Somebody said it, I heard it, thank you. If you're curious about the biochemical one, it would be NAD+, nicotinamide adenine dinucleotide. Yeah, you would need some ethanol around or something, or water, not ethanol. Biochemistry, water. What else? These two, since you wrote SPH2, you could just say mix them up. And then how did you make the precursor of the ylid into the ylid? Use the same one we used last time. I gotta take the proton off, so that's pK 30. Yeah, H- was a good one. I loved it. We got all the chemicals we need to bring these together. I got the sulfur ylid. Oh, I didn't worry about. Oh, I did worry. Sorry, never mind. Sulfur ylid. This thing belonged up here. That's where I was getting confused. I swear it got moved. I bet you watch back in the video, you'll see it get moved. Those two combined, right? Those two combined. Now my PCC is not pointing in the right spot. Tidying up a little bit. Whoa. These combine to make the target. You don't need to separate it to steps. They're just mix them together. You're home free. And then you want the big picture. Maybe. And we're done.